Welcome to On-Site Insights, a series of podcasts by On-Site Ventures about deep tech and the people behind it. We invest in the next groundbreaking idea.
Welcome everyone to the first episode of On-Site Insights. On-Site Insights is a series of LinkedIn audio events with the goal to bring our portfolio companies and the people behind these companies into the spotlight and give them a platform to present themselves. For the first episode, we have James with us today. James is the co-founder and CEO of TERASi. TERASi is a Stockholm-based startup building the future of wireless communication. So thank you for being with us today, James.
Thanks to you too. Thanks for having me, and afternoon, everyone.
All right, thanks. I want to get started with some more personal questions. So can you start off by telling our listeners a bit about yourself and your background before founding TERASi?
Sure. So I'm Irish. Maybe people can tell that, maybe not. But I've been living in Sweden now for nearly 11 years. And how I ended up here is maybe a bit of a strange journey, but I have a degree in electronic engineering that I got in Ireland. And after I did that, I spent time in both Germany and the US. And when I came back to Ireland, I felt like, I think my future is kind of outside of Ireland. So I decided to move abroad. I wasn't really sure what I was going to do. And then at the same time, I decided I wanted to continue my studies. And I actually found a very niche master's program at a university on the west coast of Sweden that I applied to and got accepted to. That led to me moving to Sweden in 2013. The master's then snowballed into a PhD. And then I had a few years as a postdoc. And as you said, today I'm one of the co-founders and CEO at TERASi. So a bit of a sideways journey to get here. But I think overall, when I look back now, it was mostly just a fun journey to get here.
Well, I'd love to hear that. Could you share a bit about the founding story of TERASi? When did you actually decide to start TERASi? Did that arise out of your research that you did?
Yeah, so the company itself is a spin-off from the university. So I did my PhD at the Royal Institute of Technology here in Stockholm. And there we were doing research into basically developing new technologies for next generation wireless. And one day back in 2020, I got an email from an old contact of mine, and they basically wanted to buy something that they had read about in my research, but they didn't know that I was the person that did the research. It was kind of a strange situation. So I replied and said, "Oh, actually, that's me. That's my research." And then they were like, "Okay, well, sure. We basically want this. Can you sell it to us?" And at the time, I was an academic and I really had no idea how to even sell something or operate a company or anything like that. But I was sharing an office with one of our co-founders, Bernard. So we were doing our PhDs together and sharing an office. And we had actually talked for a few years about it would be cool if we could take this technology and do something with it commercially. When I got this email, then we started discussing back and forth. And we just decided, let's just start a company and see what happens. There was no real business plan, no investor decks or anything like that. It was two guys with PhDs in a very niche topic. And we just decided, let's just make a company and figure things out from there. We knew that there was at least some demand and some customers interested in what we were doing back then was so niche. So we actually had it kind of as a side gig for almost 2 years. And we were doing it on the evenings and weekends. But we always had the ambition to do much more than that. And then at some point we realized, okay, there's no way to get further than this unless we have money to invest in R&D. And that was actually the point we made the decision to switch to a more classic startup approach, take in investors, go the whole school of hard knocks, figure out how to sell things, figure out the whole business plan, all of that. So we made that switch roughly at the end of 2022. And that's also when we brought in the third co-founder, Adrian, who funnily enough also did his PhD in the same group. So the company is founded by 3 guys who have PhDs in basically the same technology. So we're really the experts in what we're doing, I guess you could say. And yeah, that's how the company got started. Again, kind of a sideways path, but that's what got us here.
Well, thank you so much for sharing that story. As you know, of course, at OnSite, we constantly work with spin-outs, and it's one of our core investment themes. And we see that the process can be very lengthy and challenging for an academic that is typically concerned with research and then, dealing with all of that process of spinning out. You're based in Stockholm and you're a spin-off of KDH Stockholm. So how was the process for you spinning out TERASi?
I didn't know this at the time, But again, in hindsight, it was basically as easy as it can be for an academic spin-off. In Sweden, we're very lucky. We have what's called the professor's privilege. And that means that when you're an academic, you actually own all of the IP related to your research. And what that means when you go to make a spin-off is there's actually no IP transfer. There's no technology transfer office or anything like that. As a researcher, you can just decide to start a company and, assign your IP to it. So we didn't really have any of those challenges, which people quite often hear about when it comes to academic spin-offs. We didn't even have to go via the innovation office at KTH, but we actually decided to do it because we felt like, okay, we're two academics. Sure, maybe we want to have a company, but realistically, we don't know anything about it. So we actually approached them and said, hey, we're interested in doing this. And they helped us build up IP, apply for the first patents, talk to customers, all that kind of stuff. So it's a very different scenario than what you hear about in a lot of other European countries and also the US. But today we actually have KTH Holding, that's the university's holding company, as one of our shareholders. And that's really because we want them to be, not because we had to do it. But again, a kind of unusual situation compared to what most people would be familiar with in Europe.
Yeah, definitely an interesting insight from the Swedish ecosystem here. What was your personal motivation starting TERASi? So what actually drives you to do all this?
So for me personally, it was at the time a mix of frustration and curiosity. So I was kind of always curious about business and, how you would run a company and what it would actually mean to turn this into something commercial. And I'd also become very frustrated in academia. I was frustrated with the whole kind of funding cycle. It felt like we were inventing things just for the sake of writing papers. And I remember when I wrote my PhD thesis, I actually wrote at the end of it that someone should take this technology and commercialize it. But at the time, it wasn't obvious that I could do it myself. So when the opportunity arose then, and when I got this email, that was really kind of what sparked us off. That's the point when we said, okay, yeah, here, we're really frustrated here, but we see great potential in what we're doing and what we could do. So it was about basically harnessing those feelings and just trying to do something and learn along the way.
Okay, thanks. Shifting gears a little bit, could you explain what TERASi does? So what is your unique angle? What is unique about your product?
Sure. So we make hardware for wireless systems. I think that already differentiates us a lot from other startups in this space. We actually have our own proprietary technology, and right now we do all of the manufacturing ourselves. When I say hardware, I'm specifically talking about things like antennas and filters, but also complete modules. So you could make a transmitter or a receiver that could sit in a radio base station. And essentially what we do is we have a unique manufacturing process to make these things. And we've also now built up a technology whereby we can buy chips from external semiconductor suppliers, things like amplifiers, those types of components. We take those chips and we actually build a package around them where we connect then our antennas and our filters to it. And that's really what allows you to create a full radio using our technology. So that's kind of what we do from a very, very high level. The 5-year-old version that I like to explain to my mum is that basically we take semiconductor wafers, we put holes in them, and then we join the wafers together. That's like a very, very simplified version of what the actual manufacturing looks like. But really, the output of that process should be components and modules for wireless applications. And that can be, as I said, part of a radio system, something sitting in a base station, but it could also be for use in radar applications or mounted on a satellite to do space Earth communication, sensing, a whole host of different things.
So as you said, there are a number of applications that your technology can be used. So which markets are you going at first? What are the most interesting markets and the ones that you can tackle the easiest?
The big market in this area is, of course, wireless communications and the telecom sector. And a lot of the technology that we're developing will become extremely relevant when we move to the next generation of wireless communications. So that is when we move to 6G. But commercially, that is still quite a while away. So 6G rollout is not expected to happen until at least 2030. So our main focus right now is actually on 5G markets. And there we are specifically trying to improve the performance of radio systems by offering components and modules that have better performance or smaller size, lower weight, things like that. So that's one focus area, wireless communications and radio units. The other areas that we're looking in are, as I said, in terms of radar. So you could use our hardware as part of a very, very high performance radar system in applications like within the automotive sector for avoiding collisions, things like that. And one of the other areas that we're also looking in is in what's called SATCOM. So satellite communications from Earth to space and vice versa. And there really what we offer is a massive reduction in size and weight without compromising the performance. So for both satellite operators and satellite manufacturers, with our hardware, they could actually create very, very high capacity links between space and Earth without the usual bulk and cost that comes with conventional technologies.
Okay, got it. Maybe double clicking on the 5G and 6G technology, or I guess even more broadly speaking, connectivity. Where do you see connectivity evolving or going in the next few years? Are we on the brink of a connectivity revolution? Are we already very connected? Where do you see this going?
I think in Europe and the US, we're already very connected. If you look globally, that's not exactly the case right now. But what is clear on a global level is that the demand for wireless data is growing exponentially. So by 2030, the amount of wireless data that we consume is expected to triple. So it's a clear exponential growth. And the whole wireless industry is basically now standing at a point where they know that today's networks and today's infrastructure won't be able to support that growth. And that's really the whole kind of underlying movement towards 6G. We're at 5G today. It's not rolled out everywhere. It's not fully stable. There are a lot of improvements to be made, but it's also quite clear that we will need a fundamental shift to actually support the demand that we expect to see in the future. So if you look at what that will translate to on a practical level, as I mentioned, obviously data demand will continue to increase. And one of the ways to meet that demand is to move wireless systems towards higher operational frequencies. Why you want to move to higher frequencies? Well, there it's basically a matter of gaining access to increased bandwidth. So in a wireless system, the greater bandwidth that you have, the more capacity you can make in a wireless link. So that shift is pretty obvious, and most of the industry is aligned around that now. So we will see that as a part of 6G. And then there are also a lot of new approaches to how you implement the infrastructure that's required, both at a digital level, also on the analog level, and redesigning base stations and all of the different access points to that network. One other thing that is becoming very relevant right now and will be even more so in the future is this space to earth link. So the idea there is that we can basically provide seamless global connectivity by having wireless links to space at all times. And there, of course, you require very, very high performance and a lot of satellites to achieve that. But if you could do it, you could basically have limitless global connectivity with very, very high data rates. And that's kind of the utopian dream of wireless technology.
Got it. Double clicking on the higher frequency and higher bandwidth, therefore, where do you see challenges that the industry is facing right now in moving to higher frequency?
There are multiple challenges when you do that. So one thing is, as soon as you move to higher frequencies, the range of a given link decreases. So what that means in practice is if you say, okay, let's move to twice as high a frequency as what we use today, you would need roughly 4 times as many radio units to actually achieve the same range in your link. Mm-hmm. So that obviously creates a huge problem for the industry because you just look at it and say, okay, well, the required cost for the infrastructure will be 4 times higher, at least. And that means that in each and every radio unit, they need to start cutting costs. That's one issue, cost effectiveness. The other big one is then the actual performance of the hardware that you build these radio links out of. And their performance can be on 2 fronts. It can be related to the semiconductor chips that are used. So when you go to higher frequencies, the output power that's available from these chips actually decreases massively. So that again means you would have to shorten the range of your link. And then the other thing is all of the passive components that are required. Passive components are things like antennas and filters. And what happens when you move to higher frequencies is that they become much less efficient. So if you want to combine all of those 3 effects, basically what you have is a scenario whereby we know we're going to need maybe 10 times as many radio units, but each radio unit becomes massively less efficient and more expensive to build. That means that basically all of the big players in the wireless sector are out there looking for new technology solutions to try and solve these three core issues.
And that, of course, is where you come in. From a consumer perspective, how can TERASi actually change their day-to-day life? What does that actually mean for an end user?
Yeah, I think that's a very good question. It's a very relevant question because it's very easy to forget about this type of thing when you're an engineer. You just want to design something that performs well. If you look at wireless connectivity as a whole, you could really say that this is one of the foundations of modern society. Now, we have basically limitless connectivity between our devices in most areas. We see that this affects everything in our everyday lives. So this whole next generation shift is really about both increasing the amount of data so that you could have basically limitless real-time connectivity, but also then potentially making the whole system more efficient. So one thing that's maybe not that well known, is a bit of a dirty secret within the wireless industry, is actually the climate footprint of these networks. So there are some estimates out there that say that, okay, if we take today's approach and scale it to 6G, that by 2030, the ICT sector would account for 20% of the global electricity demand, which is kind of crazy when you think about it. So what we really see is that, particularly with our technology and what we're pushing, you can move towards a much more efficient radio system. So you would actually reduce the climate impact of the next generation of mobile. The other things that we're looking at, and I think that would affect people in their day-to-day lives, we can increase the reliability and the security of our infrastructure. So making sure that we have reliable hardware and reliable systems. And again, because wireless connectivity is so key to how we live today. And one other effect that we also see is that basically the infrastructure, if all goes according to plan, the infrastructure should actually get a lot smaller and will then become much less invasive. So if you think about how radio systems look today, they're quite often not the prettiest. They basically have big white boxes that are mounted up on radio masts. And in the future, these things could become much smaller. So you don't have basically these units, which is just infrastructure, kind of littering our cities and rooftops. So it's a kind of a multi-aspect thing. And it will take a while for these effects to trickle down to day-to-day life. But really, I think it's about more connectivity, more reliability, and higher security, basically.
Got it. Shifting gears a bit again. So you raised a seed round last year from investors such as Navigare, Almi Invest, Deep Tech Labs, and of course also Onsite. How was your experience here in the fundraise and with investors and VCs in general?
Overall, it was pretty okay. You know, it's rough. Raising capital, I guess, is always rough. Anyone that has done it will tell you that. I've heard from other people that we were in a very good position when we raised money, and we were able to target specific investors such as Onsite and try to get them on board. And we actually basically got all of our first choice investors. So we were very happy when we closed the round. Of course, it was a lot of work, particularly due diligence, things like that. That's always a lot of work. But overall, afterwards, we were extremely happy. And I think we have very good investors on board, people that have long-term incentives to support us and help us grow. That give us access to the right networks that we need.
Couldn't agree more. You definitely had everything in place. Of course, these things take time, but you surely were in a good position back then and are still, of course, now. So concluding this, what is up next? Can you elaborate on a few specific projects or initiatives that you're working on the horizon?
Sure. So I said before that 6G isn't going to roll out until 2030. We're actually already working on implementing 6G demonstrator modules. So there, what we're doing is we're working with one of our customers. They supply the chips that we're using. And as I said before, we are essentially using our technology to build around those chips and build a complete radio unit. So in this case, what we're doing is actually building a 6G module that could be used in the next generation of wireless links. And the way it's designed is actually that we can actually steer the direction of the beam that comes out of this radio unit. And this is something that's already out there today, but no one has really managed to do it in an efficient way for 6G yet. So that's one project that we're working on at the moment. And I think if we deliver what we've said and what we plan to do, there we will basically industry leading with that particular product. So that's quite exciting. Alongside that, we're working on a lot of different things in different directions, working on some space projects. and trying to get funding for those to develop next generation hardware for creating wireless links in space. So you can imagine in the future with the whole new space movement, all of the satellites will get much smaller, and we're then trying to create very compact, lightweight, high performance hardware to actually create links between those things. That's something that we're working on as well. That's quite cool. And the other big thing that we're working on at the moment is also developing and designing our own 5G module that we want to bring to market early next year. So this is actually something where it's basically like, you know, today there are Ericsson and Nokia, they have their 5G radio units, and we're basically going to try and recreate our own version of that, but do it our way and actually address the key issues that we see with their solutions.
Got it. Thank you very much, James. This actually concludes our event. Thank you to everyone for joining. Thanks for being with us today, James. And well, we hope to see you for the next episode, and have a wonderful weekend, everyone. Thank you so much.
Thanks a lot, Nick. Thanks for having me.
That was On-Site Insights, a series of podcasts by On-Site Ventures about deep tech and the people behind it. For more information on our portfolio companies and investment strategies, visit our website onsite.vc and follow us on LinkedIn at On-Site Ventures.